Okay, in this lesson, we are going to solve rational equations. So our sub-objectives are the skills that we need to be able to do that is to factor a polynomial, which you know how to do. I need to be able to determine a common denominator, which I know how to do. Determine the restricted values on the domain. So remember, what can x not be if I have a fraction? I can set up an equation, which is pretty basic, and I can solve linear and quadratic equations because sometimes this solution will come about in a linear fashion or quadratic. And so the essential question is what I want you to be thinking about throughout this is why might one of my solutions not be viable? So this is your prove it. By the end of this lesson, you should be able to do a problem like this and solve for x. So go ahead and take a minute, look at it, see if you can figure anything out. So these are my guiding questions that if I'm stuck, that kind of get me through this process. So we're going to be living with that common denominator again. So what's the common denominator? We are bringing back excluded values because our goal here is we're solving for x. So if I'm solving for x, I need to know what can x not be so that if I get one of those solutions, I'm able to eliminate it. And then like when we were adding and subtracting, what, if any, part of the common denominator does each fraction need? Once I have a common denominator, what equation can I write? Is that equation linear or quadratic? So how am I going to solve it? What are my solutions? And then are there any solutions that are restricted? So let's go ahead and get started. All right, so this first one is 1 over x squared minus 4x plus 1 over x minus 4 equals 3 over x squared minus 4x. So my first question is, what is the common denominator? So when I look at this, I have an x squared minus 4x here and an x squared minus 4x here, but this is just a regular old x minus 4. So just like when we are adding and subtracting, I'm going to factor it to make my life a little easier. So to factor x squared minus 4x, I'm going to take out an x. And then I'm going to factor this x squared minus 4x by taking an x out. So my common denominator is x times x minus 4. What are the excluded parts? So before I start moving along, this right here is my common denominator. So what can x not be? Well, in the denominator, I cannot divide by 0. So x cannot be 0. But x also cannot be, this piece right here can't be 0. So x minus 4 can't be 0. So that means that x can also not be 4. So I'm just going to keep those in mind for when I get my final answer, because if my final answer includes the numbers 0 or 4, then I have to eliminate it because those are the values that x cannot be. All right, so my third question, what, if any, parts of the common denominator does each fraction need? So my common denominator, we said, is x times x minus 4. So this one has both parts, and this has both parts. This one just has the x minus 4, so it needs the x. So when I multiply by the bottom, I need to multiply the top as well. So right now, these three fractions have the common denominator. So what's kind of nice about solving rational expressions is once they have that common denominator, I no longer need the denominator. So now I'm just going to look at the numerator to find my equation. So what equation can I write? Well, it's going to be 1 from here plus 1 times x, which is just x, and that equals 3. So what's wonderful about this is once I get that common denominator, I just have a simple equation that I solve. So is this linear? Is it quadratic? Well, this x is only to the first power. That's my highest power. So this is linear. So to solve a linear equation, I just need to get x by itself. So I'm going to subtract 1. So this has one solution. There's only one value for x that will make this whole equation true, and that is 2. Now, I always want to go back. My final question is, are there any solutions restricted? So I ended up finding that x equals 2. And I know at the beginning that x cannot be 0 or 4. Well, 2 is not 0 or 4, so I'm good, and that is my solution. So go ahead and write down any questions or places where you got lost, and I can talk about those tomorrow. All right, so this next one looks pretty simple. 1 over 2 plus v minus 2 over 2v equals 6. So when I look at this, I have 3 parts to my equation. I have 2 parts being added and what they equal to. So what is my common denominator? Well, nothing needs to be factored, so that's nice. So my common denominator is going to be 2v. So what are my excluded values? So if my common denominator is 2v, then that tells me that x cannot be 0 because I can't divide by 0. So 2v cannot equal 0, and I solve that, I get x cannot be 0. So I'm going to keep that in mind for later, that x cannot be 0. Alright, so what, if any, parts of the common denominator does each fraction need? So if 2v is my common denominator, this has 2v. This fraction over here has the 2, but it's missing the v. So I'm going to give a v to the top and the bottom. And I cannot forget that I have 3 parts to this. So technically I have this fraction over here, which doesn't have any of the denominator, so it needs both parts. So I'm going to multiply the top and the bottom by 2v. So now that all 3 parts of my equation have that common denominator, I can write an equation. So my equation is going to be v plus v minus 2 equals 12v. So I just said 1v plus v minus 2 equals, and I simplified 6 times 2v is 12v. So I'm going to combine my like terms. So really it's 2v minus 2 equals 12v. So is this linear or quadratic? Well, it's linear because I don't have anything to the second power. So I'm just going to solve a simple linear equation. So subtract 2v. I get negative 2 equals 10v. Divide by 10, divide by 10. I get v is negative 1/5. So that's my solution. And are there any restrictions? The only value that x cannot be is 0, and so I didn't get that. So my answer is v equals negative 1/5. So go ahead and write down any steps or parts of this that you did not understand, and we'll talk about it tomorrow. Alright, so this example looks pretty complicated, but we're going to work through it one piece at a time and see if we can understand it. Alright, so the first thing is I need a common denominator. So when I look at this, I see that 2 of them share this 2a squared plus a, but this one is just a 2a plus 1. So I'm going to go ahead and factor to see what pieces are missing. So 2a plus 1 cannot be factored, but I do see that this, I can take an a out. And over here, I can also take an a out. Alright, so I see that my least common denominator is going to be a times 2a plus 1. So I want to, from there, determine my restricted values. So if the denominator cannot be 0, then that means a can't be 0 and 2a plus 1 can't be 0. So the values that a cannot be are 0. And then if I set up 2a plus 1 equals 0, I would solve that, and I would end up with a cannot be negative 1/2. Because I would subtract the 1 and divide by 2. So if I had plugged in negative 1/2 in for a, I would end up with 0. So those are my restricted values that I'm just going to keep in mind until I solve my equation. So let's go back over, and what parts, if any, of the common denominator does each fraction need? So my common denominator is a times 2a plus 1, so this part has it. This fraction has it, and over here all that's missing is it needs the a. So I'm going to go ahead and multiply the top and the bottom by the a. So once I have that common denominator, what equation can I write? Well, it's just going to be what's in my numerator. So I'm going to go ahead as I write it down here, I'm going to distribute that a. So I'm going to simplify the pieces. So I end up with 5a squared plus 6a plus 1, because this didn't need any pieces, equals 5a squared plus 5a minus 100. So all I did was simplify this part, and then I set my equation up. So is it linear or quadratic? Well, this is quadratic. However, I notice that if I were to set it equal to 0, I am going to end up canceling my a squareds. So it's actually going to end up becoming linear. But let's go ahead and start solving. So I would subtract 5a squared, and that cancels. So really, I'm going to end up solving 6a plus 1 equals 5a minus 100, which is a linear. So I'm going to solve it in a linear fashion. So get a by itself. So subtract 5a, and at the same time I'm going to subtract 1. So 6a minus 5a is just a, and negative 100 minus 1 is negative 101. And I'm going to go back, and a can't be 0 or negative 1/2, which it's not, so I'm good. All right, so here's my next problem. Go ahead and pause the video and see if you can determine the common denominator. So I found the common denominator to be 3n times n minus 5. So when I factored each of these out, I noticed that they all have an n minus 5, 2 of them had a 3, and 2 of them have an n, so that makes that my common denominator. So go ahead and pause the video and tell me what values can n not be. So the restrictions on the domain are that n cannot be 0 and n cannot be 5. Because the denominator cannot equal 0, so 3n cannot be 0, and n minus 5 cannot be 0. So the values that would make those zeros would be 0 and 5. All right, go ahead and see if you can determine what parts of the common denominator each fraction piece needs. So you should have determined that this middle fraction has the whole common denominator. This fraction on the left is missing the 3, so I put the 3 on the top and the bottom. And this fraction on the right is missing the n, so I put the n in the numerator and in the denominator. So go ahead and pause the video and see if you can write out the equation that we're going to solve. So the equation that I wrote out was 3 equals n squared plus 4n plus 3 minus n. So I simply did 3 times 1 is 3 equals this, and then minus 1 times n, which is just n. So is this linear or quadratic? Well, I have an n squared here, and there's nothing over here that it'll cancel with, so it is quadratic. So to solve a quadratic equation, I need to set it equal to 0. So go ahead and see if you can solve this quadratic equation. Pause the video. Alright, so when I solved it out, I ended up with n is 0 and n is negative 3. So those are the two values that will make this equation true up here. And I always want to double check. The restrictions are that n cannot be 0 or 5, which I noticed that if n cannot be 0 and I got that n is 0, I need to eliminate that as a solution. So really, my only solution is that n equals negative 3. Because if I were to plug in 0 into all of these n's, I would end up dividing by 0, and I can't have that. So the only value that will work is n equals negative 3. So you might be wondering where I got the 0 and the negative 3 from. If you followed all of that or you ended up with that, you can go ahead and skip to the next problem. If not, I'll explain it now. So it is quadratic, so I need to set it equal to 0. So when I set it equal to 0, I ended up with n squared. I combined 4n minus n, and I got 3n, and then 3 minus 3 is just 0, so that cancels out. So generally, I'm just going to go out on a limb. Most of the problems that you see on here, you can solve by factoring. So I saw that they have a common factor, so I factored out an n. So I ended up with 0 equals n times n plus 3, because I took the n out. So I set those equations to equal to 0 separately. So n is 0 or n plus 3 is 0. Because if I multiply two numbers together and the answer is 0, one of those numbers has to be 0. So this was already solved. And then n plus 3 equals 0. I solve for n. I get n equals negative 3. All right, if you got lost in any part of that or didn't follow any of my steps, go ahead and make a note of it in your notes right now, and we'll talk about it tomorrow. All right, example 5. I want you to go ahead and pause the video and see if you can solve this one on your own. All right, so when I solved this out, I ended up with b equals negative 6. If you got that, you can go ahead and move on to the next problem. If you didn't, I'll explain it now. So when I look at these three fractions, I see that two of them have a b plus 3 and one does not have a denominator. So my least common denominator is going to be b plus 3. So what value can b not be? Well, if I cannot have 0 in the denominator, b plus 3 cannot equal 0, so that means b can't be negative 3. So if when I solve this out, I get b is negative 3, then I'm going to have to rule that out. All right, so then what, if any, of the common denominator is each fraction missing? Well, the common denominator is b plus 3, so this fraction has it. This fraction also has it, and this one doesn't have a denominator, so it's going to need that b plus 3. So what I do to the denominator, I have to do to the numerator. So I end up with that b minus 5 being multiplied by b plus 3. So what equation can I write? Well, nothing on the left-hand side of the equal sign got touched. So b squared minus 4 is going to come down, plus 1 is going to come down. And that's going to equal, and all I did was I multiplied out. I distributed. So b times b is b squared, b times 3 is 3b, negative 5 times b is minus 5b, and negative 5 times 3 is negative 15. So then I just started combining like terms. So b squared and negative 4 plus 1 is negative 3. And then I saw that it is quadratic, so I'm going to start setting things equal to 0. Well, when I subtracted b squared, the b squareds actually canceled and went away. So I just ended up with negative 3 equals negative 2b minus 15. And I see that that's linear, so I just start solving a linear equation. I added 15 to both sides and then divided by negative 2, and I got b equals negative 6. So if you did not follow any of my steps, write down specifically where I lost you, and we'll talk about it tomorrow. All right, this one looks pretty complicated, but I think you can figure it out. So go ahead and pause the video and try it on your own. All right, so when I solved this out, I ended up with two solutions, r equals 0 and r equals negative 18. If you got that, you can go ahead and skip to the next example. If you didn't, I will explain now. All right, so when I looked at these three pieces of the equation, I noticed that the least common denominator is going to be 3r plus 3. Two of those pieces have that. So what are my restricted values? Well, r cannot be negative 1 because 3r plus 3 can never equal 0. And so when I solved that equation, I ended up with r equals or cannot be negative 1. All right, so what, if any, each fraction missing from that common denominator? Well, this has all of the denominators, so this fraction's good. And this has all of the denominators, so that fraction's good. And this last piece that it's equal to doesn't have a fraction, so I turned it into a fraction with a denominator of 3r plus 3. And what I do to the numerator or denominator, I have to do to the numerator. So I ended up with r plus 1 times 3r plus 3 all over 3r plus 3. So then I wrote my equation out. So these pieces on the left-hand side of the equal sign, I just literally brought down r squared minus 8r plus 15 plus r squared minus 4r minus 12. And then over here, I started distributing and multiplying out. So r times 3r is 3r squared, r times 3 is 3r, 1 times 3r is 3r, and 1 times 3 is 3. So then I combined my like terms, and I had r squared plus r squared is 2r squared. Negative 8r minus 4r is negative 12r, and then 15 minus 12 is a positive 3. And then I combined these two terms here, and I ended up with 3r squared plus 6r plus 3. And so when I look at that, is it linear or is quadratic? Well, I have a 2r squared over here and a 3r squared over here. So no matter where I move things, I'm going to end up with an r squared. So it is quadratic. So to solve a quadratic equation, I need to set it equal to 0. So I moved these 3 pieces over to the right-hand side. So I subtracted 2r squared, I added 12r, and I subtracted 3. So 3r squared minus 2r squared is r squared. 6r plus 12r is 18r, and then 3 minus 3 is 0, so that just goes away. So to solve a quadratic, I'm going to factor, and I see that there's only 2 terms, and it's not a difference of squares, so it probably has a GCF, which it does. It shares an r. So when I divided out that r, I was left with r plus 18. So when I multiply 2 numbers together and the answer is 0, one of those numbers has to be 0. And when I solve those equations, I ended up with r equals 0 or r equals negative 18. So if I lost you at any point during that process, please make sure you note where it was, and I will answer those questions tomorrow. All right, guys, we're almost there. Like we've been doing, go ahead and pause the video and see how far you can get with this one. All right, so when I solved this one out, I ended up with only one solution, that x is negative 2. So if you got that, you can go on to the final example. If you didn't, I will walk you through my process. All right, so when I look at these 3 fractions, I look for the least common denominator. And when I factored this out, I ended up with x times x plus 1. Well, both of these had x plus 1, so the only thing that's missing is that x. So that's my least common denominator, is x times x plus 1. So before I move forward, I want to make sure that I've noted which values of x will be restricted. So because I can't have 0 in the denominator, x can't be 0, and x plus 1 can't be 0. So the 2 values that x can't be are 0 and negative 1. All right, so then I looked at each fraction and I said, okay, what are they missing to have the least common denominator? Well, this first fraction has both parts. These 2 fractions are both missing the x. So what I do to the denominator, I have to do to the numerator, and same over here. So now that they all have that common denominator, I can just go to my numerator to find my equation. So 2 just came down, and then I distributed an x to both of those pieces, and I ended up with x squared plus 4x equals, and then 1 times x is just x. So is this linear or is it quadratic? Well, I see I have a quadratic term, so to solve a quadratic, I set it equal to 0. So I subtracted that x, and then I rewrote it in standard form. So x squared, 4x minus x is 3x, plus 2 equals 0. And like I said earlier, most of these problems are going to be, the easiest way is to solve by factoring. So the factors of 2 that add to be 3, well, x plus 2, x plus 1, and those equal 0. So if I multiply 2 numbers together and the answer is 0, one of those numbers has to be 0. So when I said x plus 2 has to be 0, that means x is negative 2. And x plus 1 has to be 0, that means x has to be negative 1. But if you notice, up here, I had said that x cannot be 0 or negative 1, so I had to eliminate that. That was an extraneous solution. So my only solution is x equals negative 2. All right, final problem, guys. Go ahead and pause the video and solve this one. All right, so for this final problem, I ended up with r equals negative 4. If you got that, then go ahead and skip to the last page, and if you didn't, I'll walk you through my thinking now. All right, so when I look at this, I see I have an r plus 2 as a denominator, and then I have this big trinomial. So I'm going to go ahead and factor that trinomial, and I got r plus 5, r plus 2. So my LCD is going to be r plus 5, r plus 2, because this one already has an r plus 2, and this doesn't have a denominator. So what are the restrictions on r? Well, r cannot be negative 5 and r cannot be negative 2, so I need to keep that in mind when I get my final answer. So what, if any, is each fraction missing of that common denominator? Well, this fraction part is fine because it has both the r plus 5, r plus 2. This one has the r plus 2, so it needed the r plus 5 over r plus 5. And then over here, I went ahead and I'm going to explain why I did this. It needs both. It needs the r plus 5 and the r plus 2, which I guess I should have r plus 5, r plus 2. I didn't do the denominator. Now, in order to simplify this, I'm going to end up multiplying those back together and then multiplying it by 2. So I know that these are the same version. R squared plus 7r plus 10 is the same. It's equivalent to r plus 5, r plus 2. So I could have written this out as r plus 5, r plus 2, and then I would have multiplied that out, and I would have ended up getting r squared plus 7r plus 10. So that's why I went ahead and wrote that there, because those are the same thing. They're equivalent. So this way, all I have to do is distribute a 2 instead of multiplying the r plus 5, r plus 2 back together. All right, so what equation can I write? Well, like I said, I multiplied r plus 5, r plus 2 back together and said r squared plus 7r plus 10, and then I distributed a 2. So I got 2r squared plus 14r plus 20 equals, and then I distributed my 2 here, 2r plus 10 minus 6. All right, is it linear or quadratic? Well, I have an r squared, so it's quadratic. So to solve a quadratic, I need to set everything equal to 0. So I subtracted 2r, and then 10 minus 6 is 4, so I ended up subtracting 4. So I have 2r squared, 14r minus 2r is 12r, 20 minus 4 is 16 equals 0. And to make my life easier, I noticed that I can take out a 2. So I took that 2 out, and I was left with r squared plus 6r plus 8. Now, this 2 is no longer relevant because 2 can't be 0. So I don't really, technically there is a 2 over here, but I don't really need it to solve for r. So like I said, most of these can be solved by factoring. So since a is 1, what are the factors of 8 that add to be 6? Well, it's 4 and 2, and they're both positive. And so r plus 4, so 2 times r plus 4 times r plus 2 equals 0. So that means either r plus 4 has to be 0 or r plus 2 has to be 0. So that would give me r being negative 4 and negative 2. But if you recall my restricted values, r can't be negative 2 because that would put 0 in the denominator. So I eliminate that solution, and my only answer is r is negative 4. All right, so in your notes, what is your summary of this lesson? What are you going to need to remember? What are 3 errors you think students tend to make when solving rational expressions? And then what are your be sure to statements? So as you're looking through these problems and thinking about the things that you understand and what you don't, make sure you write down those be sure to statements, and we will talk about this tomorrow.